Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to everyone. My name is Shaharin Sulaiman. Yeah, okay. I'm from Malaysia, from University Teknologi Petronas. And first of all, I'd like to thank the organizer for inviting me to come to this place. Very nice place. So this is my first time in Azerbaijan, and I think it's really nice to meet all of you. Um, my first of all, my background. I'm a mechanical engineer. I got my first degree in America way back in 1993. Yeah. Many of you were not yet born. And then I further studied in England, UMIS, Manchester, and then continued further for PhD in University of Leeds. That was in 2007. But in between that, after graduation from my first degree, I worked as a mechanical engineer in building construction, looking after installation of mechanical systems like air conditioning, lighting, and so on, lifts. So today, I'm going to talk a bit different than the previous colleagues. So my topic is downdraft co-gasification of oil palm biomass for production of synthesis gas. Actually, this is not really mechanical. This is a bit of chemical engineering. And somehow after I did my PhD, I took a brief step to explore into this area which has a good potential. Okay, let's try to see what we have. How do we? Okay. Some introduction about my working place. Um, University Teknologi Petronas is a private university. Petronas itself is like SOCA, it's National Petroleum Company. And around 1997, the government felt that we don't have enough universities. Why send so many students to England and America? Why not let them study in Malaysia? So the company, Petronas, was asked by the government to open a university. Not just Petronas, but other companies like the electric company provider, telecommunication company were also asked to open university. So we were established in 1997, limited only to engineering, science, and technology. We don't have medical, law, and so on. And our students are relatively low, about 5,000 undergrad and 1,300 postgraduate. And in case you have never been to Malaysia, just imagine Southeast Asia, okay? Thailand, Singapore, Indonesia. Okay? So that map shows Malaysia. Bear in mind, we have West Malaysia and East Malaysia somewhere there, which is partly Borneo. Okay? So our place is at the red circle there, which is about 2 hours to the north of Kuala Lumpur. This photo is a photo of my campus. Okay, was built in 2003, and some of these are just ranking. You know, universities now they're going for rankings, and I think I don't have to talk more about that. Right. A bit about Petronas. Okay, they are a national oil company. In 1998, they built this twin tower. I think until today, it is still the tallest twin tower. Of course, there are many towers that are far taller than this, but in terms of twin, they're still the highest. And their major business is oil and gas, exploration and production, and also processing. And they were also involved in motorsport. Okay. I think one of their latest achievement is the floating plant for LNG. That means the gas is processed on the sea. So that is something that I think first in the world. Okay? Unfortunately, the price of gas today I think is relatively cheaper as compared to 10 years ago. All right, moving on. Still about UTP or University Teknologi Petronas. We have about 67%. Oh, sorry. Okay. Yeah, 67% undergrad and 18 or 19% postgraduate students. About 1/3 of them are female students. And interestingly, we have quite a large number of, not just large number, but a large diversity of international students. You can see that. Basically, Petronas do not just operate in Malaysia. They have businesses all over the world. Um, I don't think in Azerbaijan they have, but nearby is Turkmenistan. And we have a lot of students sponsored by Petronas whenever they have business in anywhere. For example, Sudan. I think Sudan is, where is Sudan? Yeah. Sudan is one of the successful business of Petronas. I think they make more money than making money in Malaysia itself. So that is one example of it. And so most of these countries are places where Petronas have businesses. These are the programs that we have. As mentioned just now, we have engineering and technology. And of course, we have petroleum and geoscience. To be frank to you, nowadays, because of the dropping price of oil, petroleum and geoscience are a bit worried. No? They're having a feeling that they may have to shut down because it is getting less popular because they are feared that there will be no job. However, two programs are stable, I would say, chemical engineering and mechanical engineering. Civil also getting less students, electrical also getting less students. I mean, this is the scenario in Malaysia. I don't know, maybe it's the same or different in Azerbaijan. I can skip this. These are the research centers in our country. Okay, now this is what the topic that I'm supposed to discuss here. It's about our Malaysia's palm oil industry. Okay, if we put aside the oil production, this is our main income. Production of palm oil, which is generated from palm oil tree. Right? Um, this histogram shows some kind of statistics of what we have in Malaysia in terms of production of palm oil. And as noted here, Malaysia is currently the second largest crude palm oil producer. About 10 years ago, we were number one, but our neighbor Indonesia has also wanted to compete with us, and nowadays they are number one. And this is one example of plantation of palm oil. It looks like a jungle, but all are trees of palm oil. Yeah. It has been an issue in Europe where they are not happy with this kind of what you call that plantation because it displays the forest. We have one of the largest or richest what do you call that forest, natural forest, and even though it still look green, but it's not the same as the rainforest. Okay? That's why to overcome this, Malaysia has adopted some kind of a certification in order to comply with the requirements of manufacturers and other importing countries. That is not the thing that I want to discuss here. What I would like to highlight here is that in operating this plantation, every month you have to prune down 2 leaves. And this leaf is not being used. It's a waste. But it is left down on the ground, unutilized, rotten to become nutrient for the trees. Okay? And here are some information about the type of waste that are generated from the tree. Okay? I can show that there is an oil palm plantation. We have the leaf, which is normally called oil palm fronds. Every 15 to 20 years, we have to cut down old trees. Then we get oil palm trunk, also not utilized, just left abandoned, rotten like that. Cannot be used to even make furniture. And then at the factory, where they squeeze the fruit to get the oil, yes, we have empty fruit bunch. Okay, empty fruit bunch. This is a waste, but nowadays it got value. A long time ago, I asked my students to go to the factory to get these things. They can get for free. Nowadays, the factory want to sell. No way you can get it free. Okay? So people are competing to get these things because it has value. Other things are also wasted, okay? But my focus in the last 10 years has been this thing, oil palm front, because nobody has really looked into it. And I think today I have some information about what I have been doing pertaining to this leaf. Okay, the word gasification here may be not familiar for you, but to give you a clue, it is a process where you burn biomass or anything without enough oxygen. Um, if you're a mechanical engineering student or chemical engineering students, you may have heard about combustion. To have a successful combustion, you must have sufficient air, right? Without enough air, it won't work. But if you have slightly enough, then your combustion become incomplete combustion, where the result is gas that can be burnable somewhere. Okay, whether you put it in engines or you you just flare it to get some kind of heat. Right? So that is meant by gasification. And okay, I can skip this. This is just to show. Oh, sorry. The pie chart here shows out of a plantation, the thing that I've been dealing with, the fronds, has the largest portion. But it has been wasted without anybody care about it. Okay? The closest use of it is as food for animal. However, that has issues because it has sharp things inside it, and when animal eat it, they will hurt their stomach. So not suitable, but maybe one day when they can, have method to remove the sharp things, it can be suitable. But for now, until today, nobody has really used this oil palm fronds at commercial level. Right? Okay, this is the front. Okay, you can study all this detail, but normally we just take the middle part and process it to become fuel. But as I said, we are only at research level. This is gasification definition. I'm not going to elaborate it further. Okay, these are the things that you can get from the gasification. Basically, gases that can combust in engines or in furnaces and so on. Um, this is the process of gasification. We're not going to spend time here. But what I'd like to show you here is that the product of gasification is you have methane, CH4, carbon monoxide, and hydrogen. They are all combustible. And to share with you, in case you don't know, during the World War II, when oil was not easy to get, the Germans, they used this method to run their tanks and tank because not enough fuel. So this was real. You can just Google and go for gasification, World War II. You can see many examples of vehicles being powered by this method. Only that after the war was over, people don't care about it because oil was easy. Right? But then, after the oil embargo of 1974, have you heard about that? I mean, the younger generation, you need to Google what is meant by oil embargo or oil crisis of 1974 when the Middle East countries refused to sell oil to the world. Right? At that time, the Americans and many Western countries started to think that we cannot rely on all these countries. We have to become more efficient. We have to find resources so that we can become, what do you call that, less relying on this oil. So gasification after that come back to the picture. Okay? Countries like Scandinavia has been using this method to generate electrical power. Right? Some examples of utilization of gasification. Okay? Basically, you can see small scale plant or large scale plant for electrical power generation. This one not so nice. I won't do this, but it has been proven by someone that they can install this plant of gasification to run a car. And there are many cars here, but at least it just proves that it can be done. I think I can skip this. We don't have much time. 2 minutes, 3 minutes. Okay, I have to run. This is what I have been doing with my students in the last, 13 years, 13 years. And we have been developing some gasifiers, okay, which are just small reactors, and the cost is very low, okay. And see, just some kind of a box, which are quite easy to fabricate, doesn't have to have high, what you call that, accuracy. You can ask anybody to fabricate it, and it can be completed in about 1 month. And the product is some kind of a combustible gas as a result of this gasification process. I'm not going to run this video, but if you are interested to see or to watch this video, you can just Google YouTube with these keywords, and you can find this video. Actually, this video is about a work from one of my internship students, not from Malaysia, but from India. He came to my place to spend, I think, about 3 months doing experiments using my experiment rig. Okay, I'll skip this. These are some of the processes involved in the research work. And in terms of co-gasification, just now, even though I mentioned that we use fronts, we would imagine that one day front also will become something that people compete to get with. So it would be good if we can blend with other materials. So these are the candidate materials that we use. This is fronds. We can also use empty fruit bunch, palm kernel shell, and can't remember this, some kind of fiber from this plantation. Can skip that. That is just a schematic of the gasification system. The picture of the gasifier, which we constructed ourselves. This one uses electricity, one of the most recent one. Some of the auxiliaries that are required to operate the system. Some result, I'm not going to spend time on it, just to show you what we've looked into, right? In order to tell whether the process or the material is suitable or not. Okay? You can ask me if you have concern on this, but I've just run through. Okay. And of course, we always look at the flame, quality of the flame. Okay. And this should be the last slide. From our work until now, okay, we managed to prove that co-gasification or gasification of these materials that we believe are potential are suitable. Okay. The only thing that is bothering us for now, the challenges, is that the price of fuel is still cheap in Malaysia. For example, RON 95 is okay in Mana, almost the same price, right? So we are almost like you. So nobody cares to use renewable energy. So they say this fuel is still cheap. Why would we use renewable energy? So probably 10 years from now, 20 years from now, then people will open their eyes, and that is the situation for now. Oh, that's the end of it. These are just some photos of my university, the library, the university campus, some of the labs. Of course, showing this is collaboration with Hitachi. And yeah, that's all. Thank you very much for your attention.
Thank you very much.